come from and where they're going to have a good appreciation for what some of the assumptions are, where some things are going, and hopefully actually build some things together and explore some things, considering that we have some interesting pieces of the infrastructure materializing here. And so today's theme is the evolution of the network. We have two gentlemen speaking. One is Deep Mehdi, and I'll give you a little bit more of an intro right before he talks, so I won't ruin the surprise. And the other one is Jeremie Miller. They've both had a long, rich history in kind of the network space at different levels, and will hopefully give you a little bit of an insight on that kind of foundation and some of the things that used to be the background, and then where they see some things going. Jeremie specifically will talk about telehash, which is kind of an application layer routing infrastructure, if you will, with some very cool elements there. But the way we want to start these things is we want to have some announcements, some conversations off the floor. Today we've invited Dr. Mehdi in order to help us start the conversation, since this is kind of the first time for the format. And then the next three are set. So we have software architectures and approaches for the next one. We also have kind of the prolific computing and algorithmic approaches, so all of the machine learning, things like that, how is that playing in the space, and also what is essentially commodity level supercomputing doing. And then the final one is next generation applications. So manufacturing, what can you do if you have almost zero latency, that kind of stuff. And we're trying to get you guys to suggest speakers and contribute and really be a part of that conversation to see what we talk about. So that's kind of the idea, billion bits, hardware, software, people that are working on applications, to see what we can do. We had a couple announcements. One was Nate Allen, so get you up here.
I also, hey everybody. I know like all of this room. I'll meet you. We should catch up. And you. Can you fix that? This is bothering me. It's supposed to be pointing out, right? Thanks. Okay, so I've been wanting to build just sort of a playground for hackers that have Google Fiber. Does anybody have Google Fiber here? A few people? All right, good. This will be a good start. Anybody getting Google Fiber soon in their house? Okay, so I want there to be a Google Fiber experiments. I want that to be a thing. I just come up with weird stuff that you think would be better on Google Fiber, or you could only do on Google Fiber, kind of like the too many kittens for broadband. The same thing that Ignite's trying to do, right? But in kind of an ongoing, really underground hacky sense. So I've set up a GitLab, which is open source GitHub, just on my home computer. And I don't really want the world to know about it because it's just on my home computer, and I don't really want like somebody hacking into my home computer and screwing it all up. But if anybody's interested in collaborating on Google Fiber experiments, that's why I've built this thing. So if you want to code and put it onto a Git that is sort of like GitHub, but it runs on Google Fiber, that's really all that's cool about it. Let me know.
Thank you. We have one more announcement, Jonathan. Two more announcements, sorry, Aaron.
Hey, everybody. Hey, everybody. I don't know as many of you as Nate, but hopefully I'm going to change that. I've got a really cool, software as a service platform startup here in Kansas City. It's for creating real-time connected applications for mobile devices, for desktop devices, for web, and for, like cool little machines like we've got running around in here. So I think might go along nicely with your fiber if you've got Google Fiber, or if you're interested in testing that out, any sort of real-time applications, if you have any cool ideas. Like for example, I've got a friend of mine who built he took an IKEA desk, or an IKEA coffee table, and he routed out and put in an 11 by 17 LED grid in there, and he's running it on a Raspberry Pi. He's got Node.js running on the Raspberry Pi, and he's got it hooked up to my service. And then random people on the internet are drawing stuff in real time on his coffee table at home, and they're taking YouTube movies and then encoding them into 11 by 17 pixels, and then like playing them on his desk and 30 frames a second, and everybody's watching it. So, I mean, just any kind of crazy ideas. If you have anything cool like that, come talk to me after the presentations here. I'd love to hear your ideas if you want to check it out. Oh, it's called Big Bang.
Big Bang.
Thanks, Ilya, for taking the lead on doing the logistics of this. I really appreciate it. February 13th, we are going to hold a launch for the a Gigabit Community Fund, and this is in partnership with Mozilla. There will be $150,000 to fund gigabit applications locally, gigabit pilot projects, really, in education and workforce development. And we're going to model the session on the Building the Gigabit City session we did a couple years ago down in the library. We'll be back down at the Central Library in KCMO. And the morning will be a little bit press conferencey. We'll talk about some of the US Ignite, Mozilla Ignite projects and some of the technologies that have been developed that could potentially be used in an educational setting. And the afternoon is really going to be devoted towards trying to get some project proposals moving. And so we've invited a lot of teachers, we've invited other people from the educational community, people from the professional community who are interested in education, nonprofits, arts organizations, anyone who has an interest in formal or informal education from K through 12 up through seniors, but would love to have the technology side represented as well, people who actually know how to do some of the stuff. I mean, some of the technologies are more mature than others. If there are brand new ideas that people want to pursue, there will be a fund available. They're not huge funds. It'll be grants between $5,000 and $30,000, looking to make 5 to 10 grants over the course of the year, but pretty exciting and certainly a conversation that this group, I think, is going to want to be engaged in. I'll send an invite out from this Eventbrite to everyone, so you'll have the details, but February 13th, put it on your calendars and let me know if you have any questions. Thank you.
Awesome. So thanks, Aaron. Thanks for the announcements, and in general, we'll hopefully have other people off the floor, and kind of the first part of the talk is really reserved and designed to kind of bring people out and talk about the cool things they're working on, and especially if they align with the theme of the week or that month's event or whatever, it's even better. So without further ado, I'd like to invite Dr. Mehdi to speak about kind of the evolution of the network, right? So the theme today is where have we come from, where have we gone? Dr. Mehdi's first professional experience, I believe, is in doing dynamic routing for telephone switches and helping to homogenize kind of a complicated, but a network that we don't think about as much anymore. And that was in the late 80s. And so he's been playing in the space for resilient networks, reliable networks, and a smorgasbord of various hardware network applications. So he's a really, really good individual to give us a bit of a background as well as a forward-looking perspective. So please, yeah. There's nobody here because it's a hangout, and the second speaker is actually going to hang out with us. And there is a live stream, but there wasn't any audience for that live stream right now. So they will know in the future.
Thanks, Ilya. Okay, where do I have to be offered a camera? Just kidding. What is a camera? Just kidding. Can you guys hear me all right? Everything is okay? Good. Thank you for asking me to speak a few words about evolution of the network. Actually, I'm not that old, so don't make me look very old. But I started using internet 30 years ago. So I was only 5 years old or something like that at that time. Because I arrived as a graduate student at University of Wisconsin in the fall of 1983. So the fall semester I didn't use it. They had the internet connectivity just then. So we had a Unix-based system connecting only universities at that time. So we had to do a first project using the system, basic stuff in the spring semester 1984, which is 30 years. So I sent my first emails back then. I cannot find that email. But and my email address from the very original domain name still works. Actually 30 years, that's pretty impressive. Only catches that they did change the domain name when it went to the .com and .edu structure around 1985. Just one, or they had to do one change. So my first address was medi at research.arpa. Every address used to be .arpa at that time. Actually, I didn't know I was going to get into networking. I was interested in optimization algorithms. I work on a distributed system funded by National Science Foundation to kind of spread distribute a large job. What you call it, map reduce nowadays, I guess. Another way to say it too, for us, distributed was, I had 20 VAX machines. That's fantastic, right? So I can distribute the problem and then solve an master-slave configuration we did. And so somebody wrote actually an API for that to write another program on top of that. So I didn't have to handle at the message passing level at that time. And the internet, so am I standing in the right place? Or if okay. So, and then at Wisconsin, actually, not immediately, only about next year or so, they started offering a course called Computer Networks. It's a special topics course, which is what we teach our undergrad right now. And so I took it in 85 or so, if I remember correctly, and everything went over my head, actually, what it was about. So nobody knew it was going to be this big at that time. So anyway, so then I went to, as Ilya said, I went to actually Bell Laboratories. They liked my sort of a little bit of a networking background, algorithms background, optimization background, and I work on dynamic routing. And that was a fascinating experience because routing was, until then, really fixed. And telephone network, they challenged themselves to say, okay, how can we make the calls dynamic? So I'll briefly talk about that for 2 minutes, I think. So the basic thing is like this. If you look at the US as a country, we have 4 time zones. So if you have a call between, say, New York and Atlanta in the morning at 8 a.m., it's what, 5 a.m. in LA. So all routing before that, it could not take advantage of the capacity sitting between New York and LA back to Atlanta. Because what? Because it is called a whole hierarchical routing, and it just is sitting there. So you basically, and capacity used to be really expensive. So the basic idea about dynamic routing is that how can you flatten the network instead of hierarchy? It's a very interesting thing because we know from a scalability point of view, you actually want to make things hierarchical. Okay, so it was great. In fact, that's how the network in telephone network became hierarchical about 100 years ago, because you cannot connect every phone to everybody. It will be an n-squared problem. They said, okay, we'll do like a tree-type structure. So that's where it went to, and they suddenly realized that we are not being able to use time-based situation where it cannot advance. So when they flattened it, they didn't flatten everything in the network. Very important. So it is break the network into 2 parts. What is called the local part, like Southwestern Bell or AT&T or Pac Bell at the time, and the core part, backbone part, connecting all the different cities, say, in the US. So you flatten that one and take advantage of, by dynamic routing, by actually routing around the calls. So one more thing. So what happens is that, do you guys know, even now probably, what's the busiest telephone call day in the country on a weekday? On a weekday. Usually it is Monday, but what's the busiest among those Mondays? Anybody know? 7 a.m. time, but what day of the year, I guess? It's the Monday after Thanksgiving. Okay, people go away for a week and they want to finish up everything and they come back. So it is the busiest one. What's the busiest non-weekday for telephone calls? Anybody have an idea? I'll give you Mother's Day. Everybody calls their mother on Mother's Day, right? So these are the 2 days. So what happens is that the traffic load on those 2, quote unquote, the peak day in the year is significantly higher. It's sort of known ahead of time, can be 20, 30, 40% higher. In the whole hierarchical routing, you'll have like 40, 50% call blocking at that time. So because they couldn't use that capacity sitting there. So with doing the dynamic routing, they could come it down to about 2% on a very high volume day. And there's a second thing we realized at the time, although dynamic routing is very good, if you have a lot of traffic in the network, actually dynamic routing is not good. So what you do is that right before, the Monday before the Thanksgiving, the routing table gets changed. In fact, in Kansas City AT&T Center, where I first came to Kansas City for my project, because they were deploying the thing we were building. And so they end of the week before Mother's Day. So they will actually go change the routing table to reduce the number of routes to about only 2 or 3 routes. So we say that if the load is not high, you want to distribute as much as possible in the network. Take advantage of it. If it is very high, reduce it, be very restrictive. Because otherwise, everybody is hunting for paths, and you cannot get actually calls through in the network. So that's sort of the very interesting thing, and that's what we learned, and we deployed it. And there are a couple of more generations. I work on another one of the routing before I came to UMKC that got deployed after that. That was a bit more adaptive and whatnot. So I guess I'm supposed to talk about evolution of the network. So I'll go back to now internet, right? So I talk about 30 years back, got connected. So we had the email and FTP, 2 applications, big applications at back that time. We were very happy. And the mail was only purely text-based mail. Nobody imagined that anybody would want to attach their picture to a mail, right? So back then, if I want to send a friend my code, email was about, well, I could do FTP, but I need a login, right, on the other machine. So that's the problem. Anonymous FTP does help. That's what we did. So what we used to do, we used to convert the binary to ASCII and attach as a text file in the email to my friend, and then said that, hey, when you get it, do the B to A conversion, A to B conversion, and get the code back and run it. And so everybody could send something. That's how we used to do it. Then MIME came in around 1988, 89. A MIME standard is basically the multimedia mail extension, which says that you can actually send an attachment instead of me personally converting it to an ASCII file and sending as a ASCII, that the MIME is taking care of that. So by the way, the mail protocol still transfer everything between 2 points as an ASCII file, still now. That's how it basically works. So this is actually very interesting why they did it, because nowhere it said you have to do ASCII, because everything underneath is binary, 0, 1 bits, right? The transport TCP protocol is all binary-based protocol. Only thing is that, as a human being, we thought, who is going to send anything? You'll just write an email like you're writing a letter. You're going to have only the letters, A, B, C, Ds, or numbers. Anything else, you don't need it. So we'll make it a simplified protocol. And so then you have to do it like this to be able to send attachments, right? So this is one thing we have done over the years with the limiting ourselves by not thinking ahead what might be. The other example is your DSL, cable modem, all the services. Because in the early, give me a 5-minute warning wherever Ilya is so that I don't go. So then the web came in around early 90s, okay? So, and everybody thought at that time, the web, people are going to do what? Only download something. Your grandmother is not going to upload a video, or you're not going to upload a video to see your grandmother to see it, right? So the thinking was that we need more for download than for upload. So when the physical layer protocols were designed at that time, which actually still, they said that we don't need to allocate as much of the physical frequency bandwidth for the purpose like DSL and cable modem for uplink compared to the downlink. Because we didn't think ahead, right? But once you do is that, like say I have I forgot the frequency, say 112 megahertz of frequency. They will put 3 megahertz only for uplink and 9 for downlink, right? So that itself actually limited it. You can do all kinds of encoding to make it better, but you cannot get past that. So that's actually what is actually still affecting us about why not thinking ahead about the thing. Only difference is now going to be with the fibers, because fiber comes in later, the protocols are different. You can do what is called time division duplexing. A very fascinating concept. Basically what it means is I like to think about like the toll booths going to the New York City. So when you go in the morning, more people are going to New York City, and you have more toll booths this way. And when you come back, you have less going this way because the other direction is more people are coming that way. So you change the allocation, right? So when you do frequency physically allocated, which is called frequency division multiplexing, you get limited by that. You can do, you can make something, but only up to a point. So the time division duplexing is sort of like that. So that thing has a delay in it from a microsecond and millisecond point of view. It's not a very well implemented concept yet, but it has been around for about 15 years now. But that actually can do that as a user at home. If I can change back and forth how much I want, like that New York City toll booth, I'm actually going to be better off in terms of what's going on with that. But then you have to think also differently, like what is happening with Google Fiber. Because if your bandwidth is too a lot, then you are not as worried about, how much it is for upspeed or downspeed, because each one is much better than what you have, as long as you can get that kind of a connectivity to that. So kind of jumping ahead a little bit in terms of what's happening with the network, is that network become more application driven from early 90s till about 5-6 years ago, from all that thing you have seen with the web, because web made the big push to be able to. I remember the first time somebody posted an advertisement on the web, a lawyer, people actually bombarded his email box with thing that you are not supposed to use that, and then his connection was completely shut off, actually. That was like 1993 or something like that. So things changed dramatically as soon as the web became very popular. So from a network point of view, there has been a thought that network has basically become stagnated in terms of what have we done in the infrastructure. Think about like the road. If I can make better roads, you can make better applications to do different things, right? You can say, oh, I can make it faster. Yeah, you can do to some extent, but there are more demanding application and whatnot with it. So with that, what we are trying to see that beside the physical capacity increase like fiber and whatnot, can we think certain things differently? So one of the things that has become pretty big in the last few years is called software-defined networking. So which idea is basically saying is that if I can software-based networking, then I can actually move things around quicker. Remember my dynamic routing I talked about earlier? Okay, so what happened to the routing then? Was routing not in the internet not dynamic? Well, actually it was not as dynamic as it could be. In fact, the large ISPs would purposefully make the routing a little bit more, quasi-static, because they want to be able to monitor how the traffic is moving through the network, because they have a bit more control. And also sometimes based on the customer request, saying that if they have a problem, they can troubleshoot much easier what happened just 5 hours ago or 5 days ago, if it is a bit more. But the main focus of dynamic routing, don't think from a software-defined networking, don't think from a backbone point of view. Think from a cloud and data center point of view. So what happened is that if I have a data center with 1,000 machines, you cannot put it on a one LAN. It won't work. It not scale it. So you can think about, go back to the idea of hierarchy. So I'm going to do hierarchy, right? That's the beauty of scalability. You can build a network in a data center, and then you can fork it out based on application. But if you do single hierarchy, it doesn't have the reliability part of it. It goes to what is called the fat tree architecture in the data centers, which is used, so that you can route around and fault around. And you don't want to use a routing in a software-defined network as much. Why? Because its routing on a time scale is much slower than when you want to move an application from one virtual machine to another virtual machine. So that's where, if you have a SDN concept, that configuration is much easier in terms of the network. But the SDN is very difficult to make it work on a larger, wide area scale. So I'll tell one more thing, and then I'll be done.
Perfect. And we kind of want to make it some more conversation, so maybe a couple questions after that as well.
So quickly switching over. So in the core of the internet, there is still a fundamental problem which is not being solved very well. Even with the data center, what is called the routing table in the core of the network is not going down. The size is going up. With IPv6, the number of bits are also going up to look for the routing table. So it's kind of growing like this, When we did the subnet concept 1994, it slowed down a little bit. So tables are going up like that in the core of the network. So that's our biggest latency bottleneck that we are facing in the next 5 years. So if we don't invent something really fantastic to do routing table lookup very efficiently, not just the hardware, algorithm point of view, we got a big problem ahead of us. Okay, so you can do certain thing by saying, oh, I'm going to partner with you, that I can reduce the size of the routing table to look at, so that I have kind of what I call is that segregated way to move around through the network. Because so that's not a global solution. So that's the biggest challenge, I think, and I don't have an answer to it. Thank you very much.
Yeah, no, perfect. If we can get a couple questions, the whole idea is to kind of keep it a little bit conversational, sort of brought it together, so it kind of turned out that way. We'll probably have about 5-6 minutes if we can get a couple questions.
Yeah, sure. Anything you have questions about, I'll be happy to answer.
So kind of a current event, the whole net neutrality case that came up. I mean, we've kind of seen where they've gotten in trouble for throttling people. I mean, how many different kinds of switches? I mean, would they be able to treat people differently or anything like that, or have any concept?
The net neutrality, well, I think net neutrality will probably come more from the user's perspective with your local ISP. Because if they try to do, well, Google search returns quicker than Bing search return or something like that, right? So those sort of a thing they can, it's a very, obviously a very interesting and a controversial topic. There are, from a purely, if you think from a market point of view, you want to allow that anybody who wants to give me more money, I want to give you, the highway instead of the by-lane, sort of an idea. But at the same time, does it going to break the basic principle of how the internet protocol and architecture works? I don't believe it is going to break to that extent, honestly, from what I have seen, whatnot. But because the subtle difference is so little, it may make a more, I think, a case for the large company without naming them to make the agreement with the ISPs to say, hey, if I go to your network, our things are going slower than this network. So it will probably more of a market tussle will be at that level rather than you and I as a user. Because we are, if you have a Google Fiber or something, that, even if you are delayed by 3 nanoseconds, you're not going to notice that, right? But for the core network, yes, they're going to be able to make some adjustment and whatnot. Okay.
Another question? Get you a second.
Home network slicing. Home network slicing.
Slicing.
Yeah, it's basically where you can customize your own home network to allow for specific kinds of data streams to come to you faster and easier. Like you can identify, like for example, on my home network, I might tweak my home network to accept and receive and send data coming from the Jamlink, the little Jamlink box, that. So one of the things I think net neutrality, it's really scary to think about net neutrality being changed to be more proprietary for certain companies' data, but I can also see the advantages of being able to tweak your own home network. So I'm just wondering, as far as to spin off the net neutrality question, does the relaxing of net neutrality allow for home network slicing?
I don't, okay, that will depend on the application. So if the, what you are trying to slice it for your home, if that is going from a particular application provider, let's say, if that application provider doesn't have a good agreement with the ISP, who is the carrier of your traffic, there is a potential that what you thought you were getting nicely sliced out is not as good as other things. That potentiality is there, absolutely there. Right.
One more question?
This may end up being too general. I'm just sort of going off the top of my head. You mentioned that our inability to look forward or our reluctance to think ahead.
Right.
And then you ended the talk with the fact that routing tables are getting so big and we're going to have to get faster at that. So if we could remove this obstacle of not thinking ahead, I guess not so much as a challenge to you, but a challenge to us, how might we think ahead as to how routing tables are going to grow? How would we solve that problem, not thinking in the present, but projecting ourselves into the future? What sort of things do we need to look at so that that's not a problem? 'Cause it sounds like the internet's going to break. Right?
I didn't say that, but you borrowed, you almost said one. Well, it's a very, it goes to a fundamental thing about how IP address works, how why the routing table itself is a problem. It solved one problem, didn't solve another problem. So if you think about IP address, it has what is called a subnet mask, right? Subnet mask, basically, what's the beauty of subnet mask? Because I don't have to have everybody's IP address on the routing table. But at the subnet mask level, I still need to have one entry for, let's say, everybody in the room. So when you do that, this goes to my flat thing, that table becomes, because the address is not based on location. So for example, an IP address assigned to UMKC is not the same from Rockhurst University, sorry, not differ by one digit in the Rockhurst University, which is down the road. So they cannot do us as an aggregation to send it to two places, right? So why? Because of the way IP address was allocated. It has no hierarchy to it. There's a beauty of it because there's a flexibility, because I can move around anywhere. That's the beauty of it. But at the same time, because that means it makes the table flat. You have to have an entry for Rockhurst, entry for UMKC, like that. And that table is what is growing. So unless we rethink how we want to do the address and how we do the masking, that problem is very difficult to solve. And then it has a secondary problem to go with it. If we come up with a new complete addressing scheme, how do we inject into the current network, right? So there, one is a kind of concept-wise, another is rolling out this thing. So we, by the way, when we went for hierarchical routing to dynamic routing in telephone network, we also faced this, how do we move it on a live network from one routing to another? So the way it was done is done on a small number of nodes. 5 nodes first, 15 nodes, 20 nodes, that's like that. You know, that's how it was deployed to about 130 nodes in the network.
Awesome.
Any other
Question?
Yeah.
Yeah, let's do one more question. We're kind of running out of time, so I'm going to ask you to keep it a little brief, and then we can kind of take it offline.
So who do you think is able today to, it seems like there's very few people that are able to help drive changes in sort of like the basic internet protocols. It seems like, 20 or 30 years ago it was easy to write an RFC and then you might be able to get people to adopt it. But today we have some really good RFCs for things like SCTP or even,
SCTP is a fantastic
protocol which you can't use anywhere, right? But see how fantastic would it be able to be to have sort of the multi-homed, sources and be able to switch back and forth, but you can't really use SCTP or, even Google's Speedy protocol. I'm not sure that everyone agrees that it's the panacea, but at least it solves some of the problems about the slow start and some of the things like that. But who now is capable of actually creating consensus? It seems like it's so difficult now to get some of those changes made.
Yeah, because the problem, well, I won't say it is a problem. The thing is that it has evolved. In a sense, network has morphed into something by itself where nobody owns anything, which is a good thing. But then everything becomes, in a sense, quote-unquote market-driven. If the protocol becomes sketchy for some reason...
Well, and also there's billions of devices that have to support it. I understand there's barriers too, but I think it makes it really difficult, or it seems to be difficult to be able to get some of those new things adopted because of that, because of the inertia.
Because when you build application on top of TCP, you have to change all the application. So, which is not easy. We would like the application to go to SCTP. It's a fantastic protocol. I teach it in my class.
Yeah.
Just as an exercise. And look how different it is. How interesting.
Look how much easier.
And it is really a lot of research went into building that kind of a protocol. But it's sitting in the middle, but not an application. There are some implementation, by the way,
yes.
but it's limited. Web have been HTTP has been implemented over HTTP, and it has been shown to work much, much better.
Yeah.
You know, I have demoed it in my class. So yeah, but it's the beyond that is very, very difficult, because now everything is driven by quote unquote Instagram application type thing, right? So what's going to catch fire right away? So
you're saying that if we could figure out a way to make it get you pictures of cats faster, that if you could put that behind it, that would get us the SCTP.
Right.
Okay, I can buy it.
Okay, one quick last comment from
Okay.
statement from my part, side,
Okay.
which is that we are. I don't know how many of you know. We did a project on YouTube measurement study from users located in Kansas City metro area. That paper is published, so if you go to my website, download it. If you have a question, I can talk about it. We wrote actually a wrapper around how to do multiple YouTube video download and do the measurements on stalling and everything. So you can see different things related to how ISPs allocate their servers for that. The follow-up is that we are actually planning to do a measurement study on Google Fiber. So we're thinking about the process. We'll probably write a small wrapper software that people can download. So I will need people who have Google Fiber to be volunteers for it. So I'm kind of making a kind of public appeal for that. I'll probably work to Aaron.
We hope to magnify that public appeal.
So, Of course, the results are public results. Of course. Yeah, just search my name, Deep
And we'll send it on all the...
Publication list. I have only one paper that has a title YouTube in it, so just download it.
Well, what we'll do is we'll actually send it to the group. We have a couple of different places.
I can.
So we'll get that taken care of.
Thank you very much.
Thanks a lot. Appreciate it. So sorry for cutting off the conversation. It was kind of jammed for time. It's actually interesting that we were kind of talking about the network stack and what you can do for routing table speed to access kind of some of the first packet in and then throughput. Because now we're going to be talking about the application layer and how can you handle a bunch of different devices. And actually, no, I'm not going to steal Jeremie's thunder here. So let me connect the Jeremie real quick. Hello, Jeremie.
Hello, hello.
Great, we can hear you. Can you see everybody?
Yes, I can.
Or I should say most everybody, and with everybody. So we just had a discussion about a lot of the things from the hardware side of the house and kind of how that's evolved and maybe some of the challenges, including lookup table times and how the internet might break. That wasn't my words, even though it may happen. And it's interesting that you kind of have been working on open platforms to connect and communicate with people. So first Java XMPP and kind of the how do you pass, packet messages, and then kind of the work that you did with Singular by combining APIs, and then also the work that you're doing with Lua, and also related to the work you're doing with Telehash, which I'm not going to steal with thunder, I promise twice now. But how do you connect and provide communication channels and services over the network? So it's interesting that we're more kind of to a software discussion. So just to kind of give you a little context, and we'll probably have you talk for until 15, 20 minutes, and then some questions if you're okay with that.
Absolutely.
And the group's kind of primed and ready to go, so we're excited to hear what you have to say.
Very cool. It's great to, sort of meet everybody virtually here. It's kind of fun that the internet enables this to happen more and more now. I just wish that Google Hangouts was a little bit better. So it's definitely a piece of technology that we need to improve upon. So I wanted to, I guess I definitely come from more in the software side, and I was thinking about this a little bit while sort of waiting here, that I wanted to, I like to think about the future and where things are going. And I've thought a lot about what might come down the road in the next 10 years, because I like to try and solve the challenges and the problems in the communication space and the software and protocol side with an eye towards what are the big problems that we're both facing now and that we're going to be facing. What are the trends and the directions? So I want to spend a little bit of time talking, in order to talk about the future, I like to talk about the past and see if I can sort of, get a sense for where, what sort of things have happened in the past that give us hints about what could happen in the future. And, as a typical human, I want to break things into, simple categories and buckets and genres and organize stuff. So I took a few notes, and looking back over like the last 30 years, my experience doesn't go back quite this far, but we're sort of in the middle of it. Looking at breaking it into like from like 1985 to like 1995. I started getting involved in computing and software in that period and in that era. And the predominant sort of communication technology back then was BBSs and LANs. The internet was starting at universities, but what most people had accessible to them was very low tech. And the big challenges, like if you look at the challenges in each one of these periods that we've overcome, back then it was time and reach. It was like the ability to reach another endpoint. LANs are very isolated, and then with BBSs and things that were networked, it often took a very long amount of time in order to actually do anything and send information and distribute information around sort of the globe. So the second generation, and it feels like, that period up to 1995, the internet was really taking off, and we started to connect to LANs, and BBSs sort of went away. They went to ISPs with dial-ins, and we overcame a lot of those challenges in that era. So the second sort of major era from 95 to 2005, I can look back and feel like the big challenges we had back then were bandwidth and accessibility. We had lots more desktops and a lot more laptops arriving, and bandwidth was always, you always wanted more. There was never ever enough. And your laptops were pretty much, they were an island upon themselves most of the time unless you were plugged into a network. And if you look at like 2005, we were overcoming that finally. We were starting to be able to get online over cellular from your laptops with the little cards you could plug in. And Wi-Fi became much more predominant, so laptops could get online in a mobile sense much more often. So we overcame a lot of those big challenges in that era. Then over sort of the last approximately 10 years, we have a lot more laptops and now tablets and phones. And it feels like one of the big things that we've sort of started to overcome is now we have the cloud, and we're starting to have good experiences. The experiences on mobile phones were, sort of pre-LTE and pre-iPhone and touch era were pretty bad. And tablets weren't even really possible until you had sort of, better technology and a lot of cloud services to support them and to support the apps. So I can look at sort of I feel like we're coming to the end of an era where we've overcome, we have the cloud, and we're having some really good mobile experiences now. We've overcome a lot of that stuff. So projecting out, into the next 10 years, I feel like the biggest, the focus is going to be a lot on apps and devices. And we hear this about the Internet of Things all the time, and everybody's building apps these days. Everything is an app, and everything is becoming appified. And the biggest problems that we're starting to face, that I feel like we're going to face, is context and compatibility. In that the context is becoming so rich about what's available. When you have your mobile phone, like the more and more sensors and the more information that's available and becoming available to the apps is creating a really rich context. And the compatibility, as we just sort of like fill up with devices everywhere around us, getting those devices to actually be compatible with each other is going to be hard. So a little bit, I'm going to be running a little bit fast here, but a little bit more about on the context side of what I see happening. We have, the predominance of LTE and cellular networks that, is pretty much always on now. And we also have Wi-Fi, and if you think about it, your phone often has two networks available to it. We're not doing a very good job of taking advantage of that yet. The fact, apps still sort of struggle, and you notice they sort of struggle if you're switching from Wi-Fi to cellular. There's sort of a period of time where stuff doesn't work, things have to reconnect. We're starting to learn how to have multiple networks available to applications, and I feel like that's going to become even much more prominent over the next 10 years. That the Bluetooth BLE is going to become sort of another network that's available. Devices are starting to mesh with each other with Zigbee, and there are a lot of work on 6LoWPAN, where all these devices are starting to create their own networks, and our phones are going to have to become aware of them in order to talk to these devices, or something's going to have to start to bridge and gateway these things. You see a lot of interest in building community mesh networks. And I feel like that's going to continue. In fact, it's going to become, the devices are going to become so cheap and easy that those things are almost going to be accidental, like they'll start to form the sort of community-wide mesh networks. And then you can actually look at like a company intranet as yet another network that's available to applications. More and more apps. I mean, one of the big things I've learned at Singly is that a lot of the big companies and even smaller ones are starting to build their own apps for their own internal use. It's sort of like replacing intranet style usage. So the contexts that we have available as far as like networking and sharing information and getting information to and from devices is expanding a lot, and I think that's going to expand significantly more over the next 10 years. And we have to think about that, think about what it means. And then compatibility. It's really like, I experience it, like I'm an advisor for one of the little Arduino, it's called Pinocchio, a little Arduino-based startup. Who's building, a little team that's building a platform for like embedded sensors and devices, and I started to get like the bleeding edge and seeing firsthand how low cost these chips are. And like, as you guys probably know, like this little main chip on here is only a few bucks right now, and it's going to be less than $1 to get something online in the next few years, and that's ridiculous. But that means that everything is going to come online. You have to like really think about what happens when we have 10 to 100 times more devices around us at any given moment that are online. And online, like I said, might be over their own little mesh network using something custom. It might be over Bluetooth. It might be Wi-Fi powered. It might be cell powered. So we're going to be surrounded by so many embedded little smart devices and so many things. And then you have to think about, these things are actually really difficult to update. And it's a very young market, so there's going to be lots and lots of variability happening, and lots of verticals, like, some refrigerators are going to be their own vertical, right? It's every little use case, these things are so cheap, becomes sort of this expansion of complexity. So getting compatibility between them, between our tablets and phones that we need to interface with, is a big problem. And like I said, it's something that we started to learn a lot about at Singly with APIs, that a lot of the device manufacturers are thinking like, oh, the best way to solve this is we have to build an API, then have the device phone home to an API, provide access, like your typical OAuth access to applications who want to use it. And it's very cumbersome, it's very heavy, and I think we're going to look back at this era of having to build an API for everything and having to ship everything through the cloud as like, sort of like the old era. If anybody's worked with like Tibco and a lot of the sort of like old networking compatibility stacks from 10 to 15 years ago, we're going to look at this stuff as very heavy and very cumbersome to work with, and sort of reduces compatibility instead of increasing it. So that's sort of where I'm coming from as far as thinking about the future and thinking about what we have to deal with from both an infrastructure side and an experience side. And I really think that we're going to see a bit of a polarization between companies solving for infrastructure and building infrastructure around, like, in certain verticals, building devices or building infrastructure as far as networking technology. And then we're going to see the other side of that polarization of companies focusing on experiences, the ones who are building apps and building really good, the best experience possible for a person. And the problems that both of those have to face, you have to think about when you're building an app in the future, you're going to have not just multiple networks, like you're starting to see the beginning of that with iBeacon and Wi-Fi Direct, more and more networks that you have to take advantage of as an app to create a good experience, more and more sensors. With the new iPhones, maps are taking advantage of emotion, right? You have more and more sensors available to tell you to create a really good experience with. And multiple displays, like AirPlay and Chromecast is just another display output for an application. And I really think our lives are going to become alive with more and more options as display outputs. You can even think of Nest as a display output, right? Your ability to change the temperature environment is actually controlling something around you. It is a display. It's an output of an application. So I guess I don't want to ramble in front of everybody, but that's what's sort of on my mind, and that's what I think about when I look at communication technology and how do you sort of solve for all of these future problems that we didn't really see coming. Like, a lot of this is catching everybody by surprise, how quickly this stuff happening and how complex it is. So there needs to be concerted effort towards making this stuff simpler and easier and better and more secure, as everybody knows. We have to care about privacy now. So I don't know if I talked very long enough, but I'd love some questions. And I guess telehash obviously is what I'm working on, is what I feel like is a really good sort of thoughtful protocol solution that addresses a lot of the challenges in the infrastructure side. How do you build an application that can take advantage of multiple networks, and how do you build privacy and security in from the foundation all the way up? How do you provide reliability when you're talking to devices versus talking to servers? That's what, as a protocol, that's the stuff that myself and a bunch of others have been working on and trying to make telehash be a really good solution for. So, all right.
Awesome.
It's question time.
Yeah, well, and we want to kind of make it conversational, so it's awesome that, thanks for the talk, it was interesting. We have an immediate question, so good. I have a couple questions too.
Where's the camera? Hey, how's it going?
Hey.
So, since we're talking about the Internet of Things a little bit here, I'm really curious what you think. Do you think NAT will die? Network address NAT, N-A-T, Network Address Translation. Do you think it will die? And
no.
What do you think the implications will it be?
NATs will never die.
Well, that's really sad.
In fact, I think it's going to get more complex and worse. The complexity of having devices sort of sitting in the middle and gatewaying to the internet, bridging to the internet, is actually going to become more complicated.
Yeah, it's just that it's been my experience that not only does that cause problems, which I'm sure you're aware of, but the fact that those devices sit there, they randomly prevent things from working, and it seems like it's going to be worse with more little tiny non-upgradable devices or hard to upgrade devices, right?
Yes, I agree. I believe it's going to get worse. So that's, of course, I have a very biased opinion because telehash is actually the solution so that you don't have to worry about NATs ever again. You can look at telehash as an overlay network such that as an application you can use telehash. Telehash is supposed to take care of, and the software that runs telehash takes care of all of the complexity of punching holes through NATs, negotiating how to open ports, using UPnP, using other servers to sort of bridge and gateway stuff. It takes care of all of that noise that happens. And fundamentally what we're trying to do is we're trying to create, like I said, an overlay network for applications to talk securely and privately to each other across any network path that's accessible to them, such that they don't have to worry about all of that complexity underneath.
I just want to say that one of the audience members asked if you had paid me to ask you that question because it was so convenient, and I was not paid by him to ask that question. I was a sincere interest myself, so that's it.
Any other questions? Okay. Here we go. Oh, yeah. So it sounds like kind of telehash being the software overlay network, you were starting to rely on the robustness and capability of other networks coming online because there's a bit of a lock-in factor with the main internet routable network. We were actually talking in a bit of a discussion earlier that it's harder and harder to build consensus for various protocol and evolution of the network, or at least that was my take on it. I could be wrong. Do you see that reliance decreasing on the main internet network, or how do you see that playing out? Let me just answer it that way.
So my deepest hope is like to set up like a community wireless mesh network right now. It's very hard because applications can't take advantage of it. Like you have to sort of custom build and hack together applications. So it's difficult to find those use cases and to make them really needed by a community. Because the internet just works, right? Cellular and the traditional backbone of the internet, it sort of just works. So you don't have a really strong need for that alternative network to exist. One of the reasons I want to have telehash have more applications that are using telehash and become more commonplace is that any app that is using telehash, as soon as you build and deploy a community network, it'll automatically take advantage of it. That the app doesn't need to be rebuilt or rethink or do anything. That as soon as another network path exists and is accessible to a device, telehash will automatically use that as the shortest path to get to the other side. And that really comes in advantageously if the internet is down, but in disaster scenarios, if you have a communication app, you want that app to continue to work. Even if there's only one cell tower up, or there's just a couple of Wi-Fi networks set up, you want those things to continue to work in disaster scenarios. And in the future, I worry a lot about the centralization of ISPs that in most major cities anymore, it's just one or two ISPs, and the control and power that they have over what is allowed on their network and what people can do with it. If we don't have easy alternatives, we're not going to have many choices. We have nothing to come back with them. We have nowhere else to go. So I want it to be very easy to have these alternative networks and let them set up and be used, and have applications not have to be rebuilt in order to use them.
That's interesting. I have another question. If we don't have another, we got a question.
What's your take on, and speaking kind of the mesh wireless and the alternative networks, community owned? I don't know if you work directly with or are familiar with, Commotion Wireless, obviously, or Free Network Foundation here locally. Do you have a perspective on sort of which of those has the most interesting or viable network architecture, and I don't know how that fits in with kind of what your work is?
I don't. So since I'm out here in Denver, I've been working with a couple of local groups on exploring what mesh networks, what we can set up here in the Denver area. Since a lot of them are, it's really community and local based. We haven't explored too much around here yet, but it feels like from all the stuff I've seen that we're very, very early on as far as what we know might be viable or what will work. Quite honestly, a lot of this tech has been figured out by the cellular industry, and the cell towers actually mesh with each other and will route calls back and forth with each other. So there's not a lot of science that has to be done. It's just finding viable purpose for it and finding good applications that people, there's a commercial reason. I do believe that the cost of setting them up and having them is going to drop significantly over the next 10 years to the point where it's almost a commodity. It's almost free to set up a wireless mesh network. So that'll help.
Jeremy, a slightly different question. What's your thoughts on IPv6 and its deployment and how it may impact anything at the application level and what you are doing for it?
Okay, so I have two thoughts. I have multiple thoughts on IPv6, and this is kind of a loaded question too. I'm working very hard to make sure telehash takes advantage of IPv6 transparently, and anytime that two telehash, nodes or switches, as we call them, detect that the other one has IPv6, it will upgrade automatically and use that. And we sort of prioritize IPv6 traffic over anything else, because IPv6 is not supposed to have NATs. It's sort of frowned upon, but so far the real world experience has been that it's still a mess. Like, IPv6 doesn't actually solve those types of infrastructure problems. So it's definitely something that Telehash is using and building on, and it should actually make it easier to roll out IPv6 when you have applications that are not hard-coded to IP addresses, or using sort of old stacks. That anything that's using telehash is using a cryptographic fingerprint to talk to the other side, so it doesn't care what actual network address it's talking to. So the thing that upsets me most is, having been sort of in the protocol world for so long, it's 2014. IPv6 design started in 1994, 20 years ago. And it was only a couple years after that where it basically solidified to what we have now. So first of all, we failed to actually roll it out. Like, it was too early as far as what the actual need was. Like, IPv4 was still really just rolling out and growing. So there wasn't a strong enough need for it back then. And now that we need it, quite honestly, it's a 20-year-old design. It's not very good at solving the problems that we're facing collectively as an industry right now. I mean, come on, it was designed 20 years ago. Even mobile devices and having, thousands of little computers online, in a 1 mile radius, it's just not, sure, there might be enough address space, but it's a very, very sort of traditional hierarchy of routing structure. It looks just like IPv4 as far as the internet backbone is concerned. It wasn't designed for devices at all. Like, 6LoWPAN is struggling to make it work well there and having to hack it, and it just doesn't feel right. So I'm not a big fan of IPv6, but I wish it existed and was rolled out at the same time.
Any idea of the mic? All right, we got another question.
Hey, Jeremy. First of all, thanks for joining us.
Yeah, it's great.
So, when you were kind of talking about, you were saying, like, think about the past and kind of the problems we were addressing in each sort of semi-decade, and then thinking about the future, right? You said you want to kind of solve these future problems. I noticed that you were sort of avoiding the term Internet of Things. Is what you're talking about different than the buzzword that has become the Internet of Things, or are they pretty closely related?
I'd say they're pretty closely related. I don't use that buzzword too much, because I don't really, when I think about it as a protocol side, I don't think about it as the Internet of Things. I think about all the little chips that are online and what they're communicating and what they're doing. I guess I would like to avoid buzzwords.
Okay, well, so then the next thing I want to ask about that, I just wanted to make sure that we were kind of talking about the same thing, is like you were talking about in each of these decades, like, we were using mobile phones, but it was a really crappy experience, or we were using BBSs, but it was a really crappy experience. So I'm trying to think of the people that are using sensors right now that are having a crappy experience, and I actually kind of struggle to come up with that demographic. So can you kind of speak to how you've decided that, like, this sensors thing is a trend? That.
So I actually cut out for a little bit. I don't know if you guys noticed.
You're actually frozen. Oh, you're back. So the basic question is, like, how I actually struggle to see this as a trend, because I don't see a lot of people using sensors right now, and right, like, all the other things were like, we were using this thing, but it was a really bad experience, and now it's good experience. So what is the bad experience with sensors right now? Like, who are the people using sensors that, like, wish they were better?
who are the people using the sensors that wish they were better?
Do you sort of understand the context? Maybe I'm going way off the rails here with this question.
So I think your question is like we've been talking about Internet of Things for a long time. And
okay, so yeah, sorry.
So that the Internet of Things hasn't happened yet, right? And is it just all talk? Is it ever going to happen? Is that kind of?
Yeah. So like you're talking about this like this is a trend, and you've decided to focus on this thing, and I'm curious, sort of like how you landed on that.
Well, I feel like it's just economics. That the price point of getting things online, getting these chips, like I was showing before, this thing is only, at the parts cost is like $10 on this whole thing, and it gets on the internet right now. And I've already seen the trend over the last few years. I've been sort of paying attention to the device space. It was $100 5 years ago, and it's down to $10. It's going to be, another 5 years from now, it's very likely going to be under $1 to get something online. And it's sort of just almost like an exponential open of possibilities that can start to happen once those things fall to each level of each price point that it drops. I guess I don't have a really good answer for what you're saying is when and maybe why not. I'm just a believer that it's inevitable.
I can work with that.
It's a good question. And another thing to consider is that a lot of people are just getting into the sensor thing with the Raspberry Pis, with the BeagleBones, and it's actually becoming a much more accessible platform from that perspective. And so,
and Raspberry Pis are like, the price point and the design of them is years old now.
Yeah.
And what is being designed and built and done right now that was going to become commonplace a couple of years from now is going to be more powerful and far cheaper. I really, every outlet, every light switch, people have been trying to do that stuff with X10 for a long time, but the price point is very high. What is a price point where that $2 outlet from the hardware store just comes with it?
So, since I have Google Fiber at home, how can I get a bunch of prototype Pinocchios to experiment with this stuff?
Well, he's actually, if you're in the Pinocchios, if you're in the Indiegogo campaign, he's actually shipping in the next week or two. And as soon as they are shipping, they're opening up for orders because they can start moving a whole bunch more. So,
and they'll be what, $5, $10?
The ones in bulk later this year will be at that price point. But the first batch of them is higher. It's just like volume cost for things. But if you email me, if you find my email address, I might be able to help prioritize an order.
I might look for that email address. Thanks a lot.
I would say, Nate, to kind of follow up on your question about, why hasn't it happened? I think part of the reason that it hasn't happened, to phrase it that way, is because people have the pain with doing it. So your dishwasher is connected to the internet. There's not like a clean interface that's like helping you monitor, energy usage. And people maybe don't care about energy usage. Like that's not necessarily the application that they want to control or like to do other light switches. But I think, you've got a lot of people that do have the things do exist, and people use dishwashers, and they use refrigerators, and they use light switches, and they use the things. They just don't use them in a connected way, and that to me is part of the problem. Like that's sort of what we're solving for, is how do you use them in a connected way. I also think on a broader scale, like if you look at cities and systems, you've got tons of sensors in usage. So you've got, like IBM and Cisco's whole smart city, initiatives. They haven't figured out how to sell these either. They haven't figured out how to market them, but they've installed them in a lot of places, and there are a lot of cities that are using, like traffic signal systems and water management systems, and they get all this data, but they don't know.
no, they're already there.
In some cases, but they do sell them. It's actually a pretty painful sales process a lot of times, but there are people buying them.
So people, when people are paying out the nose for something, then they really want it, right? And like there's a class of people that can pay out the nose for it, and in this case, maybe it's cities. And then it's later on when it becomes cheaper, then the rest of us can afford it and we all want to do it. But if nobody will pay out the nose for it, I don't see it coming to fruition. It's just sort of how I view trends as a startup guy.
I don't. So if you look at cities, like parking meters are coming online. Every single parking meter is coming online in a city. Just doesn't get replaced because the price point has dropped so far that what your offline parking meter cost is not much different than an online one, and the benefits are that much greater. Every intersection is coming online. Even if it's not a camera, the cities are actually putting the lights and sensors for those intersections online and collecting data for them because it doesn't cost hardly any more anymore if you're building on new ones or replacing stuff. And I feel like that's a trend there because those things are still very expensive, where the marginal difference of that $50 to put it online is only like 2% or whatever of the total cost of the deployment. Once it gets to in our homes, like I said, with outlets and switches, everything where decisions are made and stuff can be sensed, those things, once the marginal cost difference is low enough, they're all going to come online in the same fashion as a city is.
Yeah, that's excellent. You guys have now passed my smell test for a future trend. Like, just by bringing up cities, right? Like, no, because like now you're talking about, yes, there are giant meshes of sensors collecting lots of data. There is a real world example of this. So yes, obviously, economy of scale will bring it to the consumer market.
Okay, questions? Last question? If not, I'll ask one, and it's kind of a generic one. So out of our talk with Glenn Reichert, he started talking about some of the properties of the network, very low latency, high throughput, and it's kind of a weird perspective, I suppose, for you to ask you this question, but I'm going to ask you this question anyway and see what you have to say. Which kind of emerging property of the network has you the most excited? Is it latency? Is it throughput? Is it the existence of all these different networks? That's a pretty wide question, but we'll see what you say.
I don't have a single word like latency or throughput, but it is the availability, I think, that is most exciting to me. Is that not just one network, but making networking itself available to more things and more accessible. I want every field, to come online, every national park, every vehicle almost is already, right? I want the accessibility and availability of networking technology to be everywhere. So maybe that's it, availability.
Okay. Do you think that's going to happen through deployment or through fault tolerance and other ways of delaying the time that the data gets to the network?
I think things like Google Fiber are actually like backbones of rich internet connectivity. And everything sort of falls off. The more bandwidth and the faster it is that you have accessible to an area, everything sort of falls off from that. You hook up a Wi-Fi router to it, and it's a little bit less. Then everything that you attach and spread out from that backbone. So the backbones actually help the reach of that accessibility even further out. I don't know if I really answered the question. I think that really low cost, really horribly implemented NATs, but low-cost devices like that are going to extend the reach of chunks of bandwidth.
Okay, thank you. That's a good insight. I think we've taken the time that we said we were going to take, so I want to thank you for your time and your comments and kind of the interesting discussion that ensued.
This is great.
We will probably push the telehash links and some other things on some of our channels, so hopefully bring a little bit of traffic your way. And I think that pretty much wraps up kind of the formal teleconference. So if everybody can give Jeremie a round of applause, and thanks a lot for discussion. And I'll also send you a link of kind of the live stream just in case you're interested, because we'll be able to share that later. So, I guess this is us signing off, and thanks a lot for your time, Jeremie. Oh no, it froze. Oh, it's back. All right. Yep, take it easy.
And
How about
mostly
now?
back.
Well, yep.
All right, thanks.
All right, take care. Right. Yeah, very appropriate that it freezes up the last time. So this is kind of the general format, what we're trying to do. Please let us know what you think about the format. Let us know how we did for the other topics that we're going to have, so software architecture approaches, proliferation of computing and algorithms, as well as kind of next-gen applications, speakers, things we'd like to talk about. We'd really love to pull some of you guys working on cool stuff off the floor, do a little show and tell, kind of have a discussion about that, because that's really what this is about. Really interesting conversation that ensued, kind of from a couple of different perspectives, so that's the point as well. Yep, I've texted a fair time. Sorry about the beer. There will be beer next time. We're not sure where it's going to happen yet, but it will happen somewhere with beer. And I'm in for that. So the next meeting is, first of all, I want to thank Luis Rodriguez with Union Station. Yeah, I should have done that earlier, but thank you. We actually did a lot of stuff. He was super helpful. I was in here like 6 times. I was probably his annoying cousin that was trying to get into space. The next meeting will be February 19th. The next meeting after that will be March 19th. It just so happened that way. And then we'll have a meeting in April. It's the 3rd Wednesday. So choose whatever channel you want, whether it's Twitter, Facebook. We even have an IRC channel, which we're not really hanging out on right now. But there is an IRC channel on Freenode. Yeah? All right, so David's going to be there also, and I'll be there sometimes. IRC on Freenode, 1BBKC. Yeah, so that's the idea. I guess we're going to get a beer for some of you, and thanks for making the first one great.